Hello, everybody. I'm very glad to see you again. We continue our international summer school on data science in software engineering. And encourage you to ask questions, write emails and messages in Telegram chat. Today, we have 2 sessions of lectures. Now we start the first session, and then we have a little break and the second lecture. As for the second session, it will start at 7 p.m. Tomsk time. Moscow time, it is 3 p.m. Please check our program at website. So let's begin with the lecture, Developing a Massive Log Classification System, and the speaker is Kirill Rudakov, the lecturer of High School of Economics. Hello, Kirill. So let's begin.
Hi again. My name is Rudakov Kirill. Yeah, and today I will tell you about our research and developing project in Exactpro system, how we develop a massive log classification system. About our agenda, just a quick introduction about the scope of the project. Then I will tell you about our data, our hypothesis and analysis, and then go through other model and describe our approaches. And then I sum up our results. Okay. About the main scope of the process of our project. Generally, the main aim of the project was to help QA engineers to work with the logs to generally. Here you can find the pipeline of our project. The Exactpro launch some tests from the high-loaded systems. We obtain them, we preprocess, get some signatures. It means we delete duplicates. Yep, and then group and clustering some messages and show the QA engineers the new error or active errors to their more convenient work. Okay. About log structure. From the system, we get some log, and log consists of timeline, supplementary information, and log text. Generally, supplementary information consists of output data, application details, instant details, timeline probably obvious, and the main part where we concentrated, it's a log text. It's messages of some errors, of some information, messages, warning, etc., etc. There include executable information, some error codes, system details, and some stack traces. The next slide about our tools. Probably it's obvious too. We have the Python Devel project in Devel project, Jupyter for our idea for data science, PyCharm for our developing. Also use SQL connectors, but it's generally work with Python too. Okay, before we start, I want to tell you about the regular expressions and why we use them. Generally, the log consists of a lot of messages, and all those messages are very similar, like different by minus on the timestamp, or some IDs, or another supplementary information. And we use our regular expression, and we create regular expression to separate, to delete the redundant information, get the pure, probably pure message. But always you can't write a lot of regular expressions. And other task was to create the system that allow to combine, to glue together similar messages, similar signatures, and then the QA engineers can find them in the some groups, some types of errors, for instance. Next, about our techniques. Generally, we have a text, and machine can understand text in the raw format. Of course, we should preprocess messages, our messages. At the beginning, we should represent our messages in the machine format or number format. Generally, the main, like we work with the text, we should use the NLP techniques. NLP is the natural language processing. Yep. We have the message. There are a lot of modern techniques how to work with them. The simple and the obvious approaches is a back of words or TF-IDF. What is a back of words? For instance, we have a full sentence. There are dog, cat eats dog, etc. And we just represent these messages in a matrix. The header is our words, unique words in the all of this sentence, and the row is messages. The cross of the row and column, the number of this word in this message. Probably it's obvious. It's very useful technique, always used in many cases, but more convenient, not convenient, more useful technique is TF-IDF, turn frequency in Word document frequency approach. Then turn frequency at how many times the word you can find in this message, and in Word document frequency how many times this document, this word appears in whole dataset generally. Modern approach is a word-to-vec or fast text. In our case, we use fast text as a more modern approach. Word-to-vec was presented by Google, I don't remember, 2012 or 14, I don't remember. But for fast text, it's more modern. What is word-to-vec is all words represent like a vector. It's a word embedding. And it's a neural network. The neural network approach generally, yeah. And how in this example you can find that king is closer to man, queen closer to woman, etc., etc. All words in this space can group, and the distance between similar words small. In this case, we can preprocess our text, our messages of the log, and find the closest messages together. But on the one hand, the log messages, in log messages, we can find the natural language. But generally, there are a lot of IDs or system messages which not similar with natural language. And we decided to use the n-gram approach. N-gram approach, we have the, for instance, message which is a big data AI book. What is a unigram? Unigram is just a single word. The biggram is a couple of words. For instance, this is big data, etc. And trigram is a batch of 3 words. In our case, we combine, we use n-gram to to enlarge our model, because always in messages you can find not natural language words. Okay, next, about metrics. How to assess, how to find the similarity between two messages. It's a very important thing. We have two approaches, we have two metrics, the Jacquard and Kassan similarity. Jacquard for our sets of n-grams, Jacquard coefficient, just the union of intersection of two sets divided into their union. And cosine distance is a similarity or a cosine distance between two vectors. And it we use for word-to-vec model. Okay, next. Yeah, I tell you about metrics, about dimensionality reduction. Always the message. There are a lot of messages. We can use some different approaches for word embeddings, but we try to use PCA, and when we met some drawbacks. First of all, you can't describe your features. The features is unpredictable. For instance, you enlarge your data, and in the next step, the result of dimensionality reduction will be different from the previous step. Or you can describe what the feature is about. And we decline this approach and don't use it. About clustering, we have the word representation, message representation. We can assess them, and now we can glue together some messages and create the clusters. Why we tell about why I talk about clusters, not classification. Generally, we have only messages without classes. We didn't have the mark data, the label data. There are a lot of approaches in clustering, but generally the simplest approaches is the k-means, when you separate your space into some area. Of course, you should, before you create the clusters, detect the clusters, you should define the number of clusters. And the center of cluster is some dot on the space. Another approach is a hierarchical approach, clustering. It's similar with a tree. You have dots on the area. You find the closest. You have some value. For instance, in this, here you can find the closest dots A and B. Then you enlarge your value, your distance. Now you can combine the more dots. Then you enlarge your distance. You can combine more dots, etc., etc., and at the end you have the one clusters which represent as all dots in this scope. In our approach, k-means and chamidoids or agglomerative clustering have a huge drawback. First of all, when you train on your data and clustering, always when you want to enlarge your data, you should recluster again, and always new step is new clusters can be appeared. And generally retrain your model is very complex task. In our case, we create our greedy algorithms, which first of all detect the number of clusters, because k-means and agglomerative clustering and a lot of methods of clustering should have input has number of clusters. Of course, there are a lot of methods for detect the clusters flash, such as sellout or another approaches. But we decided to use our greedy algorithms. I will tell you about later. About the whole architecture of the model, step by step. We get the information, we reduce our documents messages, duplication by regular expressions, we use a set of anagrams of these messages, we use a word-to-vec representation. When we create a similarity matrix, pairwise matrix between all of the messages, and glue together Jacquard similarity, consent similarity, and store in this matrix. And we start our greedy algorithms, we find the closest messages and glue together and form the clusters. When and after this step, we can find the how many clusters can be formed. And when we upgrade by agglomerative clustering and have the baseline of our cluster model, then on the next day, we don't use the agglomerative clustering. We use only our greedy algorithms and enlarge our data. And the next step, and the next day, we can enlarge and enlarge and enlarge, not retrain, just enlarge. You train your model just once at the beginning. We use the threshold. I didn't mention. The threshold is it's the size of the distance, the similarity between two messages. How one message similar with another. Of course, it's one of the drawback of our approach. You should know the threshold. But about threshold, I'll tell you later. Should I repeat some? Okay, I'll go forward. Okay, about assessing our model. How to assess quality of the model. There are a lot of approaches, of course. One of the approach is a label data. The second is a generate a lot of data, synthetic data. And third is a give a look to a user for our QA engineers. Generally, probably you should go from the from top to the bottom. First of all, you should label data, then you should create the synthetic data to, and only on the last step you should give a look to a user. But in our case, first of all, we try to create the prototype to and pass it for our users. About a prototype, we use simplest tools. It's a Flask, and here you can find our design. We have a parsing our data. We store in the SQL database. When we want to clustering, we pass it for our model. Model works, and then create store in the another database, and then it can be passed to your UI. Okay, here you can find the example of our application. Here you can find the list of clusters. After training, we have a cluster 0, 1, and second. You can find the size 115, and mean density is 0.7. Mean density means that the mean similarity equals 0.7 in the cluster. For instance, if we open cluster 2, we can find that in which signature we can find here. And the first line, we number of signature. On the second line, it's a preprocessed line, and the last line we can find the original origin of the message. And here we can find that all of these messages are similar but not enough. Also, in our app, we created appearing of new clusters and active clusters. It means you add new data, you enlarge your database, then the QA engineers in this application can find new clusters, new errors probably, or active clusters. For instance, old bags, which appears again. Okay, about before when we create the app, the QA engineers can mark and label our data. For them, it very more convenient than just look at the raw messages and try to put some numbers of clusters. And of course, it help us to enlarge our models when the QA engineers marked and labeled our dataset. About synthetic data, on the base we get some quotes. I don't remember who said this, but it's the origin of the original message. The age is the issue of mine or matter. If you don't mind, it doesn't matter. When we modified this message, for instance, we add some words, we add timestamps, we add we generate random words and add some Spanish words, etc., etc. Here you can find the example of one batch of the synthetic data, and on this data we assess our model. About result, here you can find the two table for on the this column Jacquard means which Jacquard we used, used or not n-grams, and here we use or not word to vec fast text. Size option allow us to compare the size of message. For instance, one message consists of 6 words, the another consists of 10 words, and we punish our model if messages different by size. SimHash is another approach, but probably it's a redundant thing. Here you can find that for probably for all option it works nice. Here the threshold, it's now a threshold, which means the minimum of similarity to clue together two messages. And clusters, it's how many clusters we get. And homogeneity forward and homogeneity backward is how to assess the clustering. Homogeneity, it's for instance, we have the one original labeled messages, and then you try to cluster them, and you can assess them. Not it's assessing by cluster distribution. One of the approach to assess clustering models. And here you can find the best approaches, best options. You should use Jacquard with for n-grams. You may not use fast text, but use size, and also for here it's our production data. Here our synthetic data. Then homogeneity score equals 1. It means that the whole distribution are equals, not equals, the same. Okay, here you can, the number of clusters is 50. It's very close to original. Okay, about results. In this slide, you can find our assessing, our model for synthetic data. It's our greedy algorithm, not our step. Our first step, and the green is our second step when we enlarge our model, upgrade. Here you can find the best options and the worst options. When you don't use n-grams, use only fast text and without size. It means if we used only fast text, only NLP approach, we have a not very great result, the poor result. If you use the n-grams fast text with size, you have the great results. Of course, you have a I forgot the word. Extra cases, okay, you have extra cases, but generally it works. It's worked nice. Also, the 4-gram fast text, 3-gram fast text without size, and all of them very close results. Probably the main result. Okay. We done the data analysis. Our hypothesis was that if we enlarge NLP models, simple natural language model by, for instance, n-gram models, size, and other approaches, we can enlarge our model. And we create the clustering model. Also, we support this system for different SQL type and different projects, and prototyping a custom application, and assess our model by synthetic and labeled data. Boom. Probably I go fast, but it's probably all. Yeah. Probably if you have a question, I can try to answer. Okay, the question about regular expression and different symbols other than English. For instance, if we have the numbers or unpredictable words, we can delete them. Or if we have a Spanish, it's UTF-8. Or we just for this case we use the n-grams, because sometimes in our messages we can find some sequences of English, Spanish, or unpredictable. I don't know the language, and for this we use the sequence of n-grams. Of course, regular expression not allow you to you can create the regex which solve all your problems. Probably. No question.
We have another question. Just I will copy.
Okay, about method implementation, about greedy algorithm or the whole pipeline. Okay, about greedy algorithm. We have our matrix, pairwise similarity matrix. We go forward from the beginning to the end and try to find the closest messages, our signatures. The closest measured by threshold, the keyword threshold, and threshold set by user at the beginning. User by, yeah, it's empirically detected by users, QA engineers. They set this for 0.5 or similar result. And then when we label data, we can find the optimal optimal value of this threshold. Generally, you go forward for a pairwise matrix, you include together and create the clusters. Then you have the number of clusters. When you retrain your model by agglomerative clustering, you have the your training clusters. When data added, you just use our greedy algorithms to find for which clusters it can be for which clusters it belongs. About project, we have a lot of logs from some system, complex system. In our case, the fintech systems, stock markets systems, which always push new messages. There are a lot of errors, there are a lot of warnings, or just system messages, informational messages. And when you can, first of all, you can delete all information messages and use only errors or warnings. And then you try to combine them and create the family of errors. For instance, this one clusters is about errors from output, the another clusters errors of of input or from market. I don't know, example. In our words, you have a family of errors from some subsystem, and then always all errors are similar, but sometimes it can be very looks like another message, and you should glue together in the one clusters about from this family. Yeah.
Thank you, Kirill. Now, if there are some questions, please don't hesitate. No, this is not a question, just acknowledgement of your work. Thanks, thank you, Kirill. If you have some questions, you can write us at a Telegram chat or via email. So now, Kirill, I would like also to thank you, and I hope we will see you again. And we will have a break, 25 minutes break, and we will continue our lectures. And we will have a lecture of Mohamed, Elsayed, Ahmed, Mohamed on advanced optimization techniques for scheduling IoT tasks in cloud fog computing environments. So please join us in 25 minutes. Hello again, and we continue with the second lecture on advanced optimization technique for scheduling IoT tasks in cloud for computing environments. And the speaker is Mohamed Elsayed Ahmed Mohamed, professor of Tomsk Polytechnic University and Zagazig University, Egypt. Mohamed, are you here? Now we are waiting for Mohamed. He's connecting us. Let me tell you about certificate of participation. So if you wish obtaining this certificate, please contact me via our Telegram chat or email. So ask me and I will tell you everything. So we divided all participants, registered participants, in 18 groups, and we made Google Drive docs. So and I have shared the links with you via email. So please check it. And we are asking you to take notes, to take lecture notes as you wish in whatever form that you like. So please take lecture notes for you, for us, and highlight any interesting ideas. And then we will remark some lecture notes that will be very inspiring, will be interesting and good formulated. So now, Mohamed, are you here?
Hello.
Mohamed?
Yeah. Hello.
Hello?
Yeah.
Can't hear you. Mohamed? Oh,
Yeah, I hear you.
please say something.
It's okay.
Now, yes. Please say it louder.
You heard me?
I don't hear you. Say something.
Hello?
Now, yes, now it's okay. So let's begin. Okay.
It's okay. Hi, everyone. I will present today a presentation with title Advanced Optimization Technique for Scheduling IoT Tasks in Cloud Fog Computing Environment. And first of all, I am Mohamed Abdelaziz from, sorry. I am Mohamed Abdelaziz from Egypt, Zagazig University also. I belong to Tomsk University. Outline of our presentation. And the first of all, we will introduce introduction about IoT. After that, we will discuss task scheduling problem. After that, how you can solve this problem using meta-heuristic technique. After that, we will discuss the proposed method using only mixspan. The next point, we will discuss the multi-objective of task scheduling problem. And finally, we will conclusion and future work we will discuss. Internet of Things has growing as one of the prominent and significant development in the information technology fields. And this one has many applications, typically produce large amount of information that need to be processed and memorized and analyzed to get helpful decision to reach the user purpose and demands. Besides, the number and the characteristic of IoT applications are growing quickly, which need a high processing ability that even the most intelligent applications cannot currently match. A cloud environment can be a implicit platform to encourage IoT communities. A cloud computing also is recognized as a massive resource center that enable universal access to receive and produce sources to customers by virtual approaches. However, there is some limitation of the current smart devices, such as storage volume and the battery lifetime. Network devices and the processing capability can be optimized by minimizing the time cost and taking the intensive task to robust computing environment. There is another point that related to IoT is called fog computing, that is considered as an extension version of a cloud computing by assigning digital sources based on transportable users. Also, to achieve high performance for fog computing or an IoT, the job or task scheduling aim at producing high performance and cost-effective fog nodes. So, fog computing can afford less latency and less traffic jam in the network. However, this leads to extra challenges for task scheduling and resource allocation. So the main aim of our is to introduce the fog computing and improve its performance. In the fog computing, as most of us know, it is consists of 3 layers. The first layer is called cloud computing, and this one is essentially including a cloud server storing and processing massive. The middle one is called fog node, and this fog node is essentially including fog machines with specific computing power and supporting mobility. The last one or third layer is the IoT devices. These IoT devices essentially include laptop, smartphones, and car, PC machines, and sensor, and all IoT devices. So the main task of our here is to improve the process of task scheduling. So in general, we can define the task scheduling in cloud or fog computing as a process of minimizing the mix span. In general, the task scheduling in cloud computing has an enlarged processing system, and yet several things influence the work performance, such as unbalanced load and extreme resource utilization. So this process causes a high delay and load over the cloud data center. So the emergency of fog computing is essential. Task scheduling in fog computing is the commonly underlying problem to adjust the demand and resource allocation. In IoT environment, the user demand are many. Also, the performance of the fog computing platform surface is extremely higher compared to the version of cloud computing platform surface. So the main aim here is allocating the process efficiency. We need to making allocating the processes efficiency in fog computing and allocating them according to the user demand to achieve optimal scheduling in a significant problem. The time complexity of the multitask scheduling is assumed as NP hard problem, so different intelligence optimization techniques have been proposed in literature. And all of this one is some optimization techniques applied to solve the task scheduling problem. But before we understand this one, we needed to introduce the mathematical formulation of task schedule. And first of all, we are assuming that T is a collection of n independent tasks submitted to the fog broker to be processed over the proposed cloud fog computing framework. Each task has its own attributes such as task length, memory requirement, and size of input and output files and deadline. Also, we consume there is M computing nodes. Each of them has its own attributes such as memory size, such as CPU processing and network bandwidth and storage capacity. The main aim here is to compute the expected computing time of each task requested on each computing node. This expected computing time can be computed by using equation 1, that computing by divided the length of each task divided by the power of each computing node, or the processing speed of Cn. Our main objective in this study is to solve the task problem in cloud fog computing by minimization for the equation 3. Equation 3 depends on computing the ACT or find the maximum ACT along all the M computing node. So equation 3 here is considered as the main objective for us. To solve this one, there are many intelligent techniques can be used. However, we aim to using only the meta-heuristic technique here. The main motivation for us to using only the meta-heuristic or going to using the meta-heuristic is the main difference between meta-heuristic and traditional method. Traditional method here we mean by gradient descent and the Newton method and so on. First of all, these traditional methods are easy to implement. However, they are time consuming and also there exists only one solution at each iteration. Also, they are easy stuck in local point. So the superiority of this meta-heuristic techniques over traditional method in solving various optimization problems such as engineering, numerical and structure optimization, task scheduling, image segmentation, feature selection, and data clustering, and also all the application of data science, this meta-heuristic can be used. So this superiority makes the research going to using them to solve this optimization problem. In general, we can divide this meta-heuristic techniques in 4 categories. And first one is called evolutionary algorithm. Swarm intelligent is second one, natural phenomenon third one, and the last one is a human inspiration. Under each one, there is some techniques belong to this category. For example, evolutionary algorithm contain genetic algorithm, genetic programming, differential evaluation, all of them simulating some behavior for evolutionary or biological. For swarm, there is some algorithm like particle swarm optimization, anti-colony, well optimization, and so on. Natural phenomena, the most popular one may be water cycle and electromagnetic algorithm and field of force. Last one, in human inspiration. This human inspiration aim to simulate the behavior of a human, like teach and learning based optimization and football primary legal. All of this one aim to simulate the behavior of a human or natural phenomena or swarm or evolutionary. In our work, we aim of this point or this category that called swarm intelligence. In general, swarm intelligence makes simulation to swarm in nature. For example, if we consider there is one swarm and wanted to catch prey. So, in first of all, we can simulate this one in our design of algorithm by considering there is an agent or an swarm, and all of them needed to catch a prey. If the prey position is known, so all of them will catch this prey. Otherwise, if the position of prey unknown, so this swarm will distribute it in the environment and or the search space. And after that, we will determine the best of them. To determine best of them, there is many behavior in natural can be used. However, in optimization techniques, this one is called objective function. So according to the objective function, we determine best agent from all of this one that in red one. After that, each one of this agent will update its position according to this best one. After that, all of them will be updated this solution or updated its position. So we determine the best of them again according to the behavior or the fitness function in optimization problem. This process is repeated again until reached to the optimal one. This optimal one may be nearest to the prey position. This prey position in our objective function is called the optimal solution. Actually, this is the behavior of natural and how we convert it to optimization problem. According to this behavior, we using one optimization techniques that called artificial ecosystem based optimization. This one, in general, simulated the chain energy transfer over all the living organisms. By mean, there is some plant, there is some animal, there is another animal, there is bacteria. This is the life cycle for a chain energy transfer. It is first consists of 3 stages: production, consumption, and decomposition. The producer is represented in nature by plants and the bacteria. Represented the decomposer. They are considered one individual. Meanwhile, the other agents are consumers and they are classified according to the kind of food into three categories. Herbivores that eat plant, and another one is omnivores that eat animal and plants, another one that called carnivores that eat only animal. This is the cycle of each of them. I mean, this one eat plant and there is another one of animal eat this animal, and after that when it die, the bacteria is produced from this animal and then back again to produce plant. This cycle, the author of this artificial ecosystem plant optimization techniques simulated this behavior by considering the production stage to balance between the exploration and exploitation. Also, the consumption stage is used to simulate exploration, while the decomposition is used to represent exploitation. I think there is lecture previous, maybe yesterday, about meta-heuristic or evolutionary that discuss the difference between exploration and exploitation. Here, this algorithm using or converting this behavior into equation to update the position of each agent. In the first stage that called the production stage, the agent will be updated its position according to this equation. Also, this depends on selecting random solution from the population and update the current one according to it. Meanwhile, in second stage, that called the consumption, it is updated according to the equation 5. The location of current force or the location of omniforce are updated by using equation 7 and equation 8. The last stage here is called the decomposition stage, and it is updated according to equation 9. There is many details in this one. I forget this one and going to another one that called SALB swarm optimization, and finally how we can using this technique to solve the optimization task problem. The another one is called SALB swarm optimization. This SALB swarm optimization makes the simulation for the SALBs in nature, and it is presented in reference 29 in our paper. This swarm optimization, it is consists of two groups. First one is called leaders, and last one is called followers. Leaders mean here is the best fitness value, or the best fitness agents. And the last one is the followers, and this is the rest of SALBs. To update the position of followers, to update the position of leaders, we're using equation 10. After that, to update the equation, the updating equation 13 is using to update the location of followers. According to the behavior of artificial ecosystem, we will modify its behavior by combining it with SSA. The advantage of artificial ecosystem and SSA operator are combined to obtain the robust methods that can address the task scheduling problem. The proposed aim is to optimize the make span only here, task scheduling execution time, and throughput. The time measure expand in this paper to verify the quality of service required for IoT devices. Comprehensive experiments with various tasks are carried. However, the proposed method here, this is the framework of our proposed method, and to explain this one, the first stage is called initial stage, and this is the first and important point in our proposed method. Here in this equation, we generated a set of solutions. This set of solutions is generated inside the search space. This search space consists from limited from LP and UP. LP is the lower bound and UP is the upper bound. We mean here the lower bound is 1 and the upper one is M. We refer to the computing number of computing nodes. However, each solution here contains n elements. N here means the number of tasks. So, first of all, we generated a random index or a random solution using equation 14. After that, we apply the function floor. And this is the main point in our algorithm and this task scheduling when using by meta-heuristic techniques. Floor here aim to convert the real number into integer numbers. So the task scheduling problem here is called discrete optimization problem and not continuous problem. So to solve this one, we're using floor here. After we generating a random solution or a random population, we computing the fitness function for each solution and then determine the best one. After that, we apply this equation that is called the probability that depends on computing the probability for each fitness function. And after that, or according to this probability, we will determine if the current solution in the decomposition stage, last stage in artificial ecosystem, it will be updated by using traditional artificial ecosystem or according to the SALB swarm. This depends on if the probability value is greater than RS. RS here is a random number. However, in our paper, we not specify this one to a specific point like 0.5 or 0.7. Rather than we make this value or this parameter it change dynamically according to the probability of each fitness function. To do this one, we using equation 17 that depend on generating a random number inside the lower or the minimum value of probability and the maximum value of probability. This equation means that each value of RS will belong to the interval of minimum BR and the maximum BR. So this one make our algorithm is more suitable to change the probability, since the probability in first of all may be higher, after that is decreasing according to the fitness function of each solution. So this is the main idea in our algorithm, is to generate initial solution. After that, we convert it to discrete problem by using floor. After that, we using this equation of a probability and RS to update the position in the decomposition stage, that the last stage in artificial ecosystem. To evaluate the performance of our algorithm, there is several parameter and environment different parameter. For example, in the all of the experimental, the cloud fog computing consists of 2 data center. We have 2 data center. Also, we have 4 host machine and 25 virtual machine. This configuration and all environment are given in the table 1. From this table 1, we can consider the lowest and the fastest virtual machine processing is 100 and 5,000 respectively. Also, in our experimental, we're using 3 data set. One of them is synthetic, and this one is consist of 1,000 tasks generated using a uniform distribution with length from 100 to 20,000 MI. Also, we're using 2 real data set. This 2 real data set is called HPC2N, and another one that called NASA, and this one is a real data set. So this is the behavior of the first one, the 2 real data set, and this is the behavior of synthetic data set. To evaluate the performance of each one of our algorithms, we using the mix span as a measure. Also, we using the throughput and the performance improvement rate. And this is the equation of computing the throughput and the performance improvement rate. The results analysis of our algorithm is given by this one in table 5 and table 6. This is in our paper. And first of all, we can see from this one that our algorithm has the smallest mix span over all the task or the length tasks, also for real data set. Also, we can specify here that at 800 or 1000 that considered for synthetic is higher length for task, the proposed algorithm gives the best performance according to this one. Also, we can consider that the artificial ecosystem provide better results than traditional BSO or HHO or even SSA. So from this discussion, we can see that the proposed or the performance of proposed algorithm is better than other algorithms. Also for HPC2N dataset, the algorithm provide better results than other one. If we consider the average overall, we can see from this one the proposed algorithm gives a throughput better than other algorithms offer different task lengths, even for synthetic or for real data set. However, at some cases, the performance of a proposed algorithm may be nearly to the artificial ecosystem, the traditional artificial ecosystem. However, this is occurred at small tasks, but at higher ones, the proposed algorithm is better than any algorithm given in our study. Also, to discuss the behavior of artificial ecosystem or modified artificial ecosystem, according to the convergence curve, we found that it given the smallest convergence according to different number of tasks, start from 200 until to 1000. We see from the green curve that the proposed algorithm is better than other one. This is also for the synthetic one, and this is one for NASA. Now we're going to make our task scheduling problem more challenging. This one by considering multi-objective of TS problem. And first, we discuss the mix span only. But here we can add another objective to make our problem is more reliable and more challenges. We added the energy. Energy here refers to the energy consumption of the server. That represents nearly 60% of its active state. Actually, the energy or the total energy is computing by this equation that depend on the energy consumption of each computing node. And to compute the energy consumption for each computing node, we computing this one according to this equation. And finally, we formulated our objective function as this one. This objective function is considered as a bi-objective optimization problem. Actually, to solve this optimization problem, we can using different techniques. Some of them is called sum objective function or weighted objective function. Weighted objective function mean we added the two objective function that represented by mix span and the total energy and make a weighted for each of them. This weighted is represented by eta. Eta here we give the total energy, for example, 0.7. So this means we considered higher. We consider total energy or energy consumption more than mix span. If we put here 0.2, so we mean here the weighted of mix span 0.8. So we mean we considered mix span. However, in our application or our study, we put here the total energy 0.7. So we consider the energy. So since the energy is more important than actually the mix span. This is the proposed or another proposed algorithm that depend on another two meta-heuristic techniques. First one is called arithmetical optimization algorithm, and another one is called marine predator algorithm. And this is the algorithms or the two algorithms and how each of them can be used to solve the real optimization problem. However, we combine both of them according to this equation or this behavior. If a rand greater than 0.5. Actually, when we put these two algorithms by this way, we refer to each of the solutions of A or MBA can be competitive and work together in the same environment. This makes our algorithm competitive and can reach to the optimal solution faster than if we're using A of A only or MBA. Finally, we're using the previous data set, I mean the synthetic and NASA and HPC2N, and according to the fitness function behavior, we found that the proposed method that called A of A M that represented by red curves is the smallest one. This one refers that the proposed algorithm is better than other one according to the behavior of fitness value. Fitness value here that combine the mix span and the energy consumption. Also, if we wanted to discuss the energy only, not all the fitness function, we found that the proposed algorithm gives smallest energy over all the tasks and also over the three data set. Finally, in our study, we modified artificial ecosystem and applied to the task scheduling in Internet of Things. This modification depends on using the behavior of SALP swarm to improve the exploitation ability of artificial ecosystem. Also, to validate the efficiency of the developed method, we using different data set and to compare the proposed algorithm with other meta-heuristic techniques from HHO or SALP swarm or particle swarm or Firefly. The experimental results here provided that our algorithm is better than other meta-heuristic technique in most cases. Also, we modified arithmetical optimizer algorithm by using marine predator algorithm MPA to find appropriate solution for optimizing the fog computing task scheduling. Also, the developed meta-heuristic that called A of A provide better solution than the traditional one, and also it is compared with other meta-heuristic such as MRFO, MPA, SSA, and the CHIM optimizer algorithm. In future work, we can apply the modified algorithms or develop another one according to different meta-heuristic technique and apply to different data science application, starting from optimization technique or machine learning and using for forecasting or prediction or something like that. Also, we can apply for figure routing problem, job shop scheduling, or traveling salesman problem. Also, design a version of arithmetical optimization algorithm or artificial ecosystem based on SSA for multi-objective optimization in fog computing and considering more equality of service. Thank you. And I'm here for any question.
Thank you very much, Mohamed.
Thanks so much.
We are waiting for questions. Please don't hesitate to ask questions. It's very interesting. For me, a little bit complicated. So now, if there are no questions, if it is clear, and thank you again.
Thanks so much.
Now we will have some questions, not for you, but for our attendees. After tomorrow 2 lectures, we will send questions to all participants, and we will check how they understand our lectures, the material that was presented.
Okay.
So no questions. Okay. Thank you again, and I wish you a good day. Have a good day, and I think we will see you in Tomsk soon, very soon. See you.
Thank you so much.
Bye-bye.
Bye-bye.
Dear participants, now we finish our first session, and the second session for today will be at 7 p.m. Tomsk time, and here in chat you can see the link to the second session. Please check your email, check our Telegram chat, and you can see another link to the second session. The second session starts with the lecture on automated ambiguity detection in software specifications by Elena Treshcheva, program manager in Exactpro. So thank you. Now this is all, and see you in 3 hours.